Ishma, what do you use to write the assignments?
Sorry, sir.
What do you use to write the assignments?
Tab Y.
Just ask me. I mean, it is visible that it is not pen and paper. Okay, only in tab you write. Okay. मान लीजिए, okay. What about notes?
So notes I write in the book.
So notes you write in notebook. Okay. Correct. Fourth question, Hishma. Okay, and who is this? Samira. And this is Khalid. Khalid is fine. Samira, fourth one is not right. Anya's fourth one is right.
Sir, you're talking about assignment, by the way?
Talking about assignment, yeah, about the assignment.
Okay.
Okay. Achha, also, can someone check for the third question? It is a benzene ring, no? It is not it is not a cyclohexane, it is benzene ring, right?
Sir, which one? Question to third one?
Question to third one?
Yeah, benzene ring.
Hishma, आप जरा देखिए अपना assignment है ना? You have not written benzene ring there. Other things are fine. And fourth question देख लेते हैं. Hania, so tell me here, what kind of reaction is this? First of all, identify the reaction. We have seen methods of preparation, right? We have seen methods of preparation of haloalkane from alcohols, from alkane, from benzene ring, then also from alkenes, right? Then we saw halogen exchange methods. So what do you think? This is a method of preparation using what? Yes, Ishma?
Alkene.
Alkene, okay. And what is the reagent? There are two methods of preparation from alkenes, right? One is halogenation and the other is hydrohalogenation. So what do you think, which one is this?
Hydrohalogenation.
Okay. Very good. Now in hydrohalogenation, we have two cases, Markovnikov, anti-Markovnikov. So is it Markovnikov or anti-Markovnikov?
Markovnikov.
So the negative part will be added on which carbon?
The carbon having less number of hydrogens.
Okay, so now you have to tell me. This red carbon has how many hydrogens?
One.
One hydrogen. And this blue carbon has how many hydrogen?
It doesn't have hydrogen.
0. So this I will be added on which carbon, tell me? Red or blue?
Blue one.
Blue one, right? So this will be your answer. And Samira, did you see what mistake you have done?
Yes, sir.
So you have added on the CH3 और 5 bond बना दिया आपने, है ना? So one thing I should warn you is that recheck your answers. Okay, always recheck your answers. Okay. चलिए. I have not seen exactly for other answers. This is fine. Okay, so Hania, is Hania here? No, Hania has not joined, no? Okay. Other things seems fine. Solid B is fine. C is fine. Sorry. Okay. So let us move on to the next topic. So boiling point is done. Now write the topic melting point. Boiling point हो गया था ना पूरा. Branching सब कुछ हो गया था. चलिए ठीक है. Okay. Now write for melting point. See. First thing is that melting point depends on number one. It depends also on the intermolecular forces of attraction. Molecular forces of attraction. As well as it depends on what? As well as it depends on the packing. How efficiently the things are packed here. It depends on packing of the structure. And with this in mind, there is a question. So we'll write the question. From melting point, you will get only this question. That is, please write, why is the melting point of p-dichlorobenzene higher than, please write with me, okay, higher than its ortho and meta isomers. Ortho and meta isomers. Okay, so for this, you will write the answer, and the answer lies in the structure. If I draw the p-dichlorobenzene, so we have a chloro here. We have a chloro in the para position after 2 carbons. And if I draw the ortho and meta, chlorine, 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 and chlorine. So as you can see that this is completely symmetrical, and that is why it can efficiently pack. So packing of things which are completely symmetrical is going to be easy. So this is symmetrical, and both of these are unsymmetrical. Both of these are unsymmetrical, and that is why the melting point of p-dichlorobenzene is higher than its ortho and meta isomer, because p-dichlorobenzene is symmetrical, and due to symmetry, it fits in the packing efficiently. That is why they have higher melting point. Okay, so you'll write with me, due to symmetry or symmetrical structure of p-dichlorobenzene, it fits efficiently in the packing, and hence has higher melting point than ortho and para isomer. Write this down. Let me know when you're done. Done everyone? Yes or no? Please tell me.
Yes, sir.
अच्छा एक बात पूछना चाहते हैं आप लोगों से. You have to upload the assignment in the portal, right? In addition to that, can you send me your assignments also? Samaira, Khalid, Ishma,
Yes, sir.
Hania.
Right now?
No, not right now. In WhatsApp. अभी से जो assignments मिलेंगे, तो उसमें क्या होगा ना? What I will do, I will check there only, and I will tell you what are the problems. Okay. No problem with you?
No problem, sir.
Okay. So you have to you will upload in the portal and you send it to me also. Okay. And if there is ऐसा हो गया मान लीजिए that you cannot upload in the portal because it has expired, you will send it to me. Okay. Fine.
Yes, sir.
Okay. Thank you. Okay. After this, right, the next physical property, that is solubility. Now, in solubility, you will write. See, the criteria of solubility is what? Remember the criteria for solubility. What is the criteria for solubility? Like dissolves like. You remember the chapter, last lesson of solution chapter, like dissolves like. We did a few questions on this, right? Like dissolves like. That means if you have similar type of intermolecular forces of attraction in the solvent and solute, then only they are going to do what? Then only they are going to dissolve into each other. What about halogens? The halogen containing. Write this with me. Halogen containing compounds are generally polar in nature. Are generally what? Are generally polar in nature. Whereas the intermolecular force of attraction in water is hydrogen bonding. H bonding is hydrogen bonding, and hence solubility of, and hence the solubility of haloalkanes is lower in water. Done everyone? Yes or no? Please tell me.
Answer.
Okay. Solubility हम लोगों ने किया तो नहीं था ना. Right, next. Alkyl halides are more polar than aryl halides. And therefore alkyl halides are more soluble in water. Okay, so Rx has more solubility than ARX. You'll also get a question in NCERT, which will be asking you about the solubility of cyclohexyl chloride versus chlorobenzene. Okay, so here whose solubility will be higher, A or B? Tell me, guys. Which will be higher, A or B?
A.
Yeah, correct. A will be higher. Why? Because A is a haloalkane and it is more polar. It is more polar. Okay. Now, why it is more polar? Look at the reason. The carbon here is sp3 and the carbon here is sp2. But both of them are having halogen. Both of them are having what? Both of them are having halogen. And that is why the difference in electronegativity is higher here than the difference in electronegativity of the carbon and chlorine bond in aryl halide, right? Because sp3 carbon, they have lower electronegativity. sp2 has higher electronegativity. Chlorine also has higher. And that is why the difference between these two will not be very much high, right? And that is why the since the electronegativity difference is very low in haloarenes, they are less polar. So write this down. Let me know when you're done. Then everyone is on, please tell me.
No, sir. Give me a second.
Okay. So I will explain this as a physical property only about dipole moment. So please write the dipole moment of haloalkane is greater than the dipole moment of haloarene. Why? Since the CX bond of haloarenes have partial double bond due to resonance, which lowers its bond length. Also, the CX bond of haloarenes ARX has sp2 carbon, which has higher electronegativity, which leads to lower difference in electronegativity. Okay, lower difference in electronegativity. Now, both of these things, they combine, and what do? They decrease the magnitude of dipole moment. Due to above reasons, the magnitude of dipole moment, which is equal to Q into D. So Q will relate to what? The difference in electronegativity. Since you have CX bond, the delta positive and delta negative, they will not be very much higher here. They will be very low. The difference in electronegativity is low here. And the next is distance. And since you have a partial double bond, which will lower the distance of bond, and that is why the distance between the positive and negative charge will be lower, and hence what will happen? The magnitude of dipole moment will decrease. Due to the above reasons, the magnitude of dipole moment is lower in haloarenes than haloalkane. Okay, so Rx have higher dipole moment than ARX. Write this down. Let me know when you're done. Done, everyone? Yes or no? Please tell me. Nabil Ahmed, Assalamu alaikum. Nabil, are you there? Your mic is off,
Yes,
by
sir.
the way.
Yes, sir. Welcome, sir.
That is Nabil Khan. There is also one more Nabil. Nabil Khan, this is your first class?
Yes, sir.
You have not got any trial?
This is the first one.
First one, na? Okay, okay. I just want to speak Nabil Ahmed. Okay, I don't know. You can't unmute or what? Nabil Khan, which school are you enrolled in?
International Indian School, Jeddah.
Jeddah. Okay, fine. And which chapter is, how many chapters are completed there?
2 solutions and electrochemistry.
Electrochemistry.
Yeah. Chapter 2 and chapter 3.
Okay. So what are they going to complete next? Any idea?
No, sir. No idea.
No idea. Is there anyone here from Indian International School of somewhere else? Dammam, या फिर Riyadh or
Sir, me, sir. Tamam.
Dammam? Anya, okay. आप लोग के यहाँ तो solution के बाद haloalkane haloarene पढ़ा रहे हैं. Samaira also.
Yeah, sir. Almost done that chapter.
Haloalkane haloarene is almost done.
No, sorry, sir. Haloalkanes
Alcohol?
is done. Alcohols and phenols almost done.
Oh, okay, okay. But ये इंटरनेट, बट आप लोग का तो मिड टर्म जो होगा, यू ऑल विल हैव, जो भी इंटरनेशनल स्कूल में पढ़ते हैं IIES में, चाहे वो जद्दा हो, दमाम हो, रियाद हो, they all will have the same paper, right? Or no idea?
I don't think so, sir.
I don't think so. Okay.
No, sir. Not the same paper. They'll
Not the
have
same
different-
paper.
Yeah. Like that.
So they can have different chapters also. Like syllabus भी अलग होगा मिड टर्म का.
No, syllabus will be same.
मिड टर्म का syllabus same होगा.
Yeah.
That means these people will learn electrochemistry. बाद में, ठीक है। लेकिन आपको फिर दूसरे बैच में आना पड़ेगा नबील खान।
सर इलेक्ट्रोकेमिस्ट्री का टेस्ट हो गया ऑलरेडी।
तो जरूरत नहीं है क्या, इलेक्ट्रोकेमिस्ट्री आपको नहीं पढ़ना है?
पढ़ना तो है बट रिवीजन में।
अच्छा ठीक है, आपका इलेक्ट्रोकेमिस्ट्री आपको चलता है, आता है।
जी जी।
अच्छा ठीक है, ओके ओके। I will still give you I will see if there is a playlist. I will give you the recordings, okay? Electrochemistry is going on. I will also ask them to give you the link for that class. If you want to join that class, then you can also come some days. Okay? Fine.
Yes sir,
Chaliye.
sure.
Okay. So I think all of you have written till here. Now, whatever I'm going to teach from now on, I hope so. Haloalkane, haloarene, you have not done any class, right? So I should give you some questions that you can cover up. Now you have holidays, right? So Nabil, I have given you a playlist. So from this playlist, you will complete the haloalkane, haloarene first, okay? And once you watch the lecture, and if you have any doubts or something, then you will message me. Okay? Are you added in any groups till now?
No sir.
No? Okay, fine. Can you send your number? Send me a number जिसमें आप हमसे बात करना चाहें.
Yeah, okay. Sure.
Okay, send in chat. Okay, then I will add you in the group. Chaliye. So all of you will concentrate from here. Now this is completely different topic. We are going to talk about the chemical reactions or the reactivity of what haloalkane and haloarene. So, chemical properties of haloalkane and okay, Nabil, I will add it. Haloalkane and haloarene. Okay, so there are three main reactions that you will be seeing for haloalkane and wait a second. Haloalkane hi likhi abhi, not haloarenes. Okay, write only haloalkane. Haloarene we will discuss in a separate topic. So please write haloalkanes primarily show the following reactions. Now, following types of reactions, and these are types of reactions: nucleophilic substitution, second, we will be studying elimination, and third, we'll be studying reactions with metal. Okay, so these are the three topics that we will be studying. Now, all of you please write nucleophilic substitution reactions. Please write the topic.
Point Vinicius, sir, a minute.
Yeah, sure. Right.
Okay, sir. Thank you, sir.
Okay. So now all of you write the topic nucleophilic substitution reactions. Nucleophilic substitution reactions. Nucleophilic substitution reaction, it is abbreviated as Sn. S, and there is a subscript जब आप x square लिखते हैं तो this is what superscript. Okay, and if you write x and there is 2 here, it is known as subscript. Okay, so Sn, n is in the subscript. Nabil Khan, what other subjects do you have?
Maths, chemistry,
And
and IP.
maths, chemistry, physics नहीं है क्या आपके पास? You have physics, right?
Yeah, physics as well. Yeah.
Physics and IP.
Yeah.
IP or IT?
IP, informatic practices.
Oh, okay. IP, I thought it is intellectual property.
Yeah,
This is
basically it's computer science.
Intellectual property is a subject of law, and intellectual property, it is about, if I write a particular article, then someone cannot write the same thing. So how do we keep track of those things and what are the laws related to that? That is IP, intellectual property. But you are learning computers, copywriting. Copyright is different. Copyright का मतलब थोड़ा दूसरा हो जाता है. हाँ, there are two words. एक होता है copy. You are saying the right thing. The one thing is not copywriting, and one thing is copyright. So copyright is the word. If you are using it, yeah, that is the word that I mean. Copywriting is something else. When you write ads and all, or if you are writing anything, that is known as copywriting. I don't know why it is called, but it is called copywriting. Fair. Let us focus on nucleophilic substitution reactions. What are nucleophilic substitution reactions? Please write. Let's define this. A reaction in which a group, for this case halide. What I will be teaching about nucleophilic substitution reaction, it will be general nucleophilic substitution reactions. Okay, and after that we will talk about the specific reactions of haloalkane. So I am writing a reaction in which a group, in this chapter halide, of substrate, that means organic reactant, substrate is replaced by a nucleophile, is called nucleophilic substitution reaction. Nucleophilic substitution reaction. Okay. In general, how we write this reaction, you have Rx, in which this X atom is what? It is halogen. It may be fluorine, chlorine, bromine, or iodine. And there will be a nucleophile. In the reaction, what will happen? This nucleophile will be getting attached on carbon, and this X negative, this X will do what? This X will leave. Okay, this X will leave. So the specifics that you have to remember for this type of reaction is, what is the bond broken? So CX bond is broken always. In nucleophilic substitution reaction, CX bond is broken and C nucleophile is bond, which is formed. Write this information also.
Sir, what does nucleophile mean?
सब आएगा अभी. Nucleophile, है ना? What is this group? Nucleophile is basically a electron rich species. Okay, anything which is electron rich, that will be nucleophile. Nabil Khan, that was you. Okay.
Yeah, yes, sir.
आपको थोड़ा सा भी टाइम लगेगा, बिकॉज हालोअल्केन हालोरीन आपके स्कूल में भी नहीं हुआ है ना, और अब बीच में भी आए हैं थोड़ा सा. ठीक है, आप पूछते रहिए इसी तरह से. ठीक है, just keep asking like this.
Sir, can you give, sir, do you have playlist for IUPAC naming also?
IUPAC naming.
Yes, sir.
Salman, do you remember I gave you IUPAC naming from my channel? आपने देखा था क्या, Salman?
Yeah, I did see it, but I don't remember the channel.
No, not channel. Was it helpful? I'm asking that.
Somewhat, yeah.
Okay.
If I wanted to revise, I would check that, yeah.
Acha, okay, fine. Then I can give that because it is difficult to find for from the Learnivio channel. Let's see. So Nabil Ahmed, you asked, or Nabil Khan?
Me, sir.
Ahmed.
Sir, send the link to me also.
Send link to you also. Nabil Ahmed. You should watch from the second or the third part. Okay. First part is typical introduction. You don't need that.
Yes, sir.
Okay. Watch from the second or the third lecture. So there's like 10 minutes, 20 minutes, or sometimes even lesser. Chaliye. So nucleophilic substitution reaction. Okay. Now, in Sn, what is happening? Please write the points with me. Okay. Please write the points with me. In Sn, nucleophilic substitution, one base is replaced by another base. What is base? Base for you is what? An electron rich species. देखिए OH negative, right? Negative है ना? OH negative, it is what? It is base. So आप यहीं से याद रखिएगा. Water bases are those substances which have high electron density. Okay, high electron density or negative charge is present. Those are bases. In Sn, one base is replaced by another base. Actually, this is a definition of base by Lewis. Okay, it's replaced by another base. Right, next, the incoming base that means nucleophile, right, is called nucleophile. And the outgoing base is called leaving group. Okay, it's called leaving group. For the feasibility of, please write, for the feasibility of reaction. Acha, now you guys will tell me, nucleophile is coming and it is replacing X, right? Nucleophile is coming and it is replacing the leaving group. So what do you think, which should be stronger, nucleophile or X? Which should be stronger?
Nucleophile.
The nucleophile will be stronger, right? So for the feasibility of reaction, incoming base, feasibility means for the reaction to happen, incoming base, that is nucleophile, should be stronger than outgoing base, that is outgoing base is known as what? Tell me.
Leaving group.
Leaving group. Should be weak. Done everyone? Yes or no? Please tell me. Can I move on?
Yes.
Okay. Right, next. Two things happen in Sn that we have written previously also. Two things happen in nucleophilic substitution. First thing is cleavage of CX bond. That means breaking of CX bond. Second thing that happens is formation of carbon nucleophile bond. Okay. These are the two things happen. Now you won't write after this. And on this basis, the two things which are happening on this basis, what I can do, I can classify, I can say that there are two types of Sn. Types of nucleophilic substitution. There are two types of nucleophilic substitution. Sn can either happen in one step or two steps. There can be, please don't write these things. Sn in one step. Or Sn can happen in two steps. Sn in two steps. Okay. Sn in one step and Sn in two steps. All of you have written above this red line. Is there anyone who is still writing? No. Okay. Tell you. No. Okay. So types of Sn in one step and Sn in two step. So if I see the Sn in one step, then what we will see? We will see that there is nucleophile plus there is Rx, and this nucleophile will attack here, and then this X will leave like this. So you will form a bond that is nucleophile R plus there will be X negative. But if the if the Sn is happening in two steps, then the first step will be the breaking of Rx bond. That is what you will be getting. The more electronegative atom, that is halogen, it will get the electrons. R will get positive charge and X will get negative charge. So this is a carbocation. We are forming a carbocation here. Okay. And the next step will be what? For this, the next step will be the R positive will be attacked by nucleophile. So nucleophile will attack here like this. Okay. It will be having at least a lone pair electron. Okay. At least one lone pair electron. It will attack on the R positive and it will form RNU bond. Okay, so it can happen either in one step or it can happen in two steps. Now, if we see which of these two reactions, in these two reactions, if I see the rate of the reaction, that means how fast the reaction is happening, how fast the reaction is happening here. So in this first step and second step, you guys will tell me, what do you think which is going to be slower?
First step.
The first step or second step?
First step.
First step. Others, what do you think? First step or second step? What is going to be slower? First step. Okay. Raise your hand if you know the reason. Raise your hand if you know the reason. Okay. Nabil, tell me what is the reason? Nabil Ahmed.
Because it involves the bond breaking between hydrogen and between the halogen and
halogen and carbon. Yeah, correct. Hania, same reason?
Yes, sir.
Okay. So see, yeah, this bond breaking will always be slower. Okay, and that is why this is not even slower. This is reversible in nature. This is reversible in nature. Right? After R positive is formed, X negative can also attack the R positive rather than getting attacked by nucleophile. Okay, so this is what this is kind of reversible in nature. Now this is slow. So right there, slow, and this will be fast because we have a positive charge and can be easily attacked here. This will be fast. Okay. Now the question is, if we have two steps, then let me ask you one tricky puzzle. Let us say you have t-shirt, you have a shirt, and you have a jeans. So t-shirt takes, let us say, 5 minutes to dry. Shirt takes, let us say, 10 minutes to dry. and jeans takes 15 minutes to dry. So tell me what will be the total time to dry in the chat? Total time taken.
50 minutes.
Send me in chat na answers. Send your answers in chat. Salman ko yaad aa gaya. हाँ Salman. Okay. What about others? Okay, Khalid. Okay, okay Nawal. Okay Hishma. Okay Hania. Nabil Khan, I'm waiting for your answer. ये इसका जवाब तो आप दे सकते हैं नबील, yes or no? Nabil Khan. Nabil Khan, are you not here?
Yes, sir.
Write in chat now. What do you think? How much time will they take? Okay, Samaira. Time taken to dry. Nabil Khan, you have to send answers to Salim. Nabil ने तो बिल्कुल अलग ही जवाब दिया है. Okay. Okay. अभी नबील अहमद को समझ आया. Okay. Nabil Khan, can you explain your answer? Why 20 minutes? It's Nabil.
Yes, sir. I did not understand it.
What did you did not? What you did? Sorry.
5, 10, 15. I did not get it.
So you, I'm saying that t-shirt takes 5 minutes to dry, shirt takes 10 minutes, jeans take 15 minutes. I'm asking what will be the total time taken to dry?
15 minutes.
15 minutes. Okay, fine. So all of you understood that the step which is slowest, that is determining the rate. Yes or no? How fast all of the steps are happening, that is determined by what? Which one? The slowest step. And in this case, the first step is what? The slowest step. That is why that will be your rate determining step. So here the rate determining step is RDS. We say rate determining step is the first step. Okay, it is the first step. Okay, and rate, it will be directly proportional to the number of Rx molecule. If you have a very large number of Rx molecule, so that is why the rate will be very much fast if you have large number of Rx molecule, rather than if you have less number of Rx molecules. So they will not collide and they will not be participating in reactions. And if you look at here, the rate will be proportional to both the things because this is the only step. If we have more number of nucleophile and more number of Rx bond, then the rate will be higher. Okay. Now, since here the rate is dependent on two molecules, it is known as bimolecular and it is known as unimolecular because rate is dependent on only one step, unimolecular. Okay, bimolecular is known as bimolecular nucleophilic substitution. So it is abbreviated as Sn2 since there are two molecules on which the rate depends, and this is abbreviated as Sn1. Okay. Well, all of you remember this. These 2 and 1, it tells you about what? It tells you about the number of molecules on which the rate depends. Chaliye. All of you got this? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Sn1 and Sn2. Okay.
Yes, sir.
Moving on. You will write the types of Sn. ऊपर वाला कुछ नहीं लिखना था. आप लिखिएगा types of Sn. Sn1, Sn2. Write the number 1. Sn1. It refers to unimolecular nucleophilic substitution reaction. Refers to unimolecular nucleophilic substitution reactions. The reaction in which, if they ask you to define Sn1, you will write this statement. The reaction in which rate depends on concentration of substrate only. In this chapter, the substrate will be alkyl halide. Substrate only is known as Sn1. Is known as Sn1. For this, rate law is equal to, the rate law will be R is equal to the rate constant K multiplied by the substrate, which is Rx here. Or you can also write R is equal to K into substrate. Now, order of reaction is the power of the concentration term that we have in the rate law. So order of reaction, अब ये देखिए, these topics are of chemical kinetics, okay? Chemical kinetics आप लोग के स्कूल में पढ़ाया नहीं गया, सीधा haloalkane haloarene चार्ट स्टार्ट कर दिए वो लोग. Order of reaction. Order of reaction is what? It is the power to which the concentration term is raised. The power of concentration term, okay? A sum of the power of concentration term वो आपको Sn2 में समझना है. Order of reaction यहाँ पे कितना हो जाएगा? 1. And molecularity. So since this is unimolecular, it will be 1. Molecularity is also equal to 1. Write this down. Let me know when you're done. Done everyone? Yes or no? Please tell me. Is there anyone who's still writing?
Done, sir.
No, no one is writing. Okay. Right, next, the mechanism. So how Sn happens? It happens in 2 steps. It happens in 2 steps. The first step is cleavage of CX bond. Cleavage of CX bond. So please say cleavage of CX bond or formation of carbocation. So you have carbon atom which is attached with some 3 groups, and one of the atoms is halogen atom. And in the presence of polar solvent, solvent is bipolar. We will also talk about this. Present of polar solvent, this bond is broken and you get a carbocation plus X negative, plus X negative. Second is formation of CNU bond. Or attack of nucleophile. Always remember, whenever the attack happens, whenever you are drawing this arrow, it should be starting from an electron source. It will start from either a bond or a lone pair, and it will end up towards the electronegative atom or towards the positive charge or something, electron poor site. So here what will happen? Carbon with a positive charge, and you will have a nucleophile. This nucleophile will obviously having a lone pair. Attack on this carbocation, it will form carbon nucleophile bond. This is going to be fast, and the above one is obviously reversible, hence it is slow. Is there anyone who is still writing?
Yes, sir. Sir, first one, what is the word? A.
Cleavage of CX bond.
Cleavage, okay.
Cleavage of CX bond, formation of carbocation, formation of CNU bond, or attack of nucleophile.
Then
Then okay. Is there anyone who's still writing? No. Okay. Right, next Sn2. What number did I give? Hash, okay. It refers to bimolecular nucleophilic substitution reaction. The reaction in which rate depends on both the substrate, in this chapter it is alkyne halide, and the nucleophile, is called Sn2. Here the rate law is R, rate is equal to rate constant K to Rx and nucleophile Nu. Okay, so this has power 1, this has power 1, and if you add those powers, the order will be equal to 2. And molecularity, since it is bimolecular, its molecularity is also 2. Done everyone? Yes or no? Please tell me. Is there anyone who's still writing? No. No, no. Okay. Now write mechanism. So here what happens? Cleavage of CX and both steps cleavage of CX bond and formation of CNU bond takes place simultaneously. So you'll write the mechanism like this, okay? So you have carbon, you have X here. Wait a second. Write the nucleophile first now. Backside attack happens here. So the nucleophile, it will attack carbon like this because it is delta positive, so it's delta negative. The halogen will simultaneously leave and we will get a transition state. Don't draw this box, please. Don't draw this box. And then what will happen? You will see that nucleophile okay, so it is forming bond with carbon, and at the same time, the carbon halogen bond is being broken. Carbon halogen bond is being broken. Okay, this is known as transition state. How many of you have seen Harry Potter?
I've seen.
Raise your
All.
hand now. If you have seen Harry Potter, raise your hand. Okay. So you'll understand if you have seen Harry Potter. I don't know. I have just seen this in the context of transition state because is there someone who can turn into wolf? Is one of the teachers of Harry Potter. He can or she can turn into wolf when there is full moon or something. Wolf or some other animal, some other creature.
Yes, sir, wolf.
Wolf only. There is one character, right? So while it is transitioning, that character is in so much pain, right? Yes or no?
Yes.
Similarly, here also, whenever the transition happens, in transition, this molecule will be having a very high energy. Okay, this molecule, it will be having very high energy. It will be very unstable. So transition state is always very unstable. Okay, so after this transition state, let me draw one more thing. Let me draw this in blue. So this bond is getting formed and this bond is getting broken. After that, you will see carbon and nucleophile bond. Okay, and halogen is here. So you can see that this is a backside attack. This is the backside attack. Write this down. Let me know when you're done. Done, everyone? Yes or no? Please tell me.
Yes, sir.
Okay. Now we will look at the factors affecting. Now we will look at the factors affecting Sn1 and Sn2. Factors affecting Sn1 and Sn2. The first factor we will look is the nature of substrate. That is your Rx. Second, we will look at the nature of leaving group. That is your X negative. Third, we will look at the nature of solvent. Third, we will look at nature of solvent. Write the first topic. Nature of substrate. Factors affecting Sn1 and Sn2. That means how is the nature of substrate affecting the reactivity or the rate of how fast the particular Sn1 is going on or Sn2 is going on. Okay. Factors affecting Sn1 and Sn2. That means these factors, they affect the rate of reaction. They affect how fast the reaction is going on. Okay. So nature of substrate. If I look at Sn1, then you can see that it is forming what? It is forming carbocation. And this step is slow. If this step gets faster, that means this step is going to determine the rate of reaction. And in this reaction, in this particular step, we can see that the most unstable is what? It is the carbocation. And if the carbocation is formed easily, if the carbocation is stable, it will be formed easily and the reaction will be faster. And hence the reactivity of Sn1 is directly proportional to stability of carbocation. Please write nature of substrate. In that, first of all, we will look at the reactivity of Sn1. Reactivity of Sn1. So reactivity of Sn1 is directly proportional to the stability of carbocation. So whenever you are given to write the order of reactivity or write the order of rate of reaction for Sn1, you will draw the carbocation and you will check which of them is more stable. So in starting, you will have to draw the carbocation, but after a while, what you will be seeing, you'll be seeing that you are habituated and you can easily tell which of the following is more stable. So for example, if you have been given these molecules, okay, please don't write now. Please see, you have been asked to place them in the increasing order of rate of Sn1. Rate of Sn1. The molecules that you have been given is CS3X. You have been given CS3, CH2X, CS3, CH2X. Then you have been given CS3, CHX, and there is one more CS3 here, followed by CH3, carbon, one methyl group above and one methyl group down, and there is a X atom here. So all of the halogen atoms are same. Okay, all of them are fluorine. So that means what we are doing, we are not comparing the rate of reaction on the basis of halogen atom. Halogen atoms here are same. So in order to tell the rate of reaction, what we will do, we will form the carbocation. How will you form the carbocation? You will just remove this X, CH3 positive. Make the same thing, CH3, CH2, remove this complete bond with X, and you will draw a positive charge here. Okay, for the rest of these two, please write the structures and send me in chat. Write the structure and send me in WhatsApp. Okay, not chat, WhatsApp. And Nabil, I'm just sending you a hi. Okay. Nabil, where are you originally from? Nabil Khan. Nabil Khan, are you there?
Yes, sir.
Where are you originally from?
I'm from Hyderabad.
Hyderabad. Old, new?
Sorry.
Don't. Old Hyderabad, new Hyderabad. There's an
New, I
old
guess.
city, na? New,
Yeah,
I guess.
new one, yeah.
What is your DP, Nabil? Some cartoon character. Okay.
Yeah,
I've just
sir.
sent you a salam, and just try to draw the pictures. You can draw the structures, na? Yes or no? Nabil?
Yes, sir. I'll try.
You just need to remove the X, and from wherever you have removed X from this carbon, then you will add a positive charge here.
Sir, do you include my number in the group?
Nabil Ahmed.
Yes, sir.
नहीं include किया हमने आपको. Okay, Nabil Ahmed, I have. Wait a second. Okay, so you have your own photo in the DP. Yes, Nabil Ahmed.
No, sir.
No. Okay, so this is some
Send you
different
my number,
Nabil.
sir. No?
Send your number then. Some different Nabil Ahmed. Khalid, correct. Saifullah. Oh wait, अच्छा आपने भेज दिया. Okay. ऐसे काट कूट के भेजा बिल्कुल सैफ आपने. हाँ. Draw it properly, okay? Or you can cut it very clearly. You will draw a circle like this and then cut it, okay? मतलब सारे चीज को कट कर दिया आपने. Okay, सैफ. Samaira, correct and correct. हिश्मा. नबील एक काम करो, ये सारे तो हमको बच्चे भेजने लगे ना. यू सेव माई नंबर, ओके? हम आपको अपना नंबर भेज देते हैं, आप उसमें भेज दीजिए हमें.
Sir, which Nabil?
नबील अहमद. हाँ, हिश्मा करेक्ट. हानिया ने भेजा फिर डिलीट कर दिया. ओके हानिया. Nabil Khan, you got my message, na? Nabil Khan?
Yes, sir.
Okay. Draw the structures and send it to me. Anya has sent it now. सही है. Correct, Anya. So who has not? Hania, Hishma, Samaira, Saif, Khalid, Nabil. So Salman, Nawal. Nawal, are you there? Nawal नहीं है क्या क्लास में? Yes, Nawal. Can't unmute. Nawal is not here. Okay, who else? Others are here. Okay, fine. Salman. Yeah, correct, Salman. So this is one of the skill that you have to create. That is to make carbocations. Formation of carbocation. Okay. Nawal nahi hai. I have to check with Nawal what happened. CS3, CH. CS3 and this carbon will get a positive charge. Okay. This carbon will get a positive charge. Here.
Sir, I
Yes,
sent you.
Okay, Nabil Ahmed. Correct. Some of you have drawn here. ठीक है. तो आपकी क्लास में चलेगा, ओके, बट अगेन टेलिंग यू गाइस व्हाट आई हैव ड्रॉन इट इज अ बेटर पिक्चर, ओके, लेकिन आपके क्लास में वो भी चल जाएगा जो आपने भेजा है, those I have drawn here for this one. Nabil Khan, I am waiting for you. Nabil Khan,
Yes, sir. 1 minute.
ये पेन और कॉपी लेके नहीं बैठे थे क्या आप? अभी बैठे हैं? जल्दी भेजिए। Samaira, you have not sent. Samaira? नहीं, Samaira आपने भेज दिया। I am really sorry, Samaira. You have sent me answer. Sorry. हाँ, everything is right, Nabil Khan, but this bond will be not here, है ना? जो आपने last structure में बनाया CH3, CH3, and a positive sign will be here. ऐसे bond बना दिया हमने. That bond will be not there. Okay. So this is methyl. This is 0 degree. This is 1 degree. This is 2 degree, and this is 3 degree carbocation. So I hope you remember from your 11th standard, and also that the CSC groups are electron releasing group. They are electron donating group. So they will donate electron to this carbon, and they will stabilize the positive charge. They will stabilize the positive charge. Okay. So that is why this 3 degree will be most stable, followed by 2 degree, and followed by 1 degree, and then followed by 1 degree. And the same will be the rate for what? And same will be the rate for Sn1. The same will be rate for Sn1. Please write this down. Let me know when you're done. All of you understood this? Yes or no? Please tell me. Stability of carbocation will be directly proportional to the number of methyl group that is attached. Methyl groups, these are electron releasing group through plus I effect and also hyperconjugation. And that is why 3 degree is most stable, and hence the 3 degree alkyl halide will show reactivity, very high reactivity towards Sn1, very high reactivity towards Sn1. Done everyone, yes or no? Please tell me.
Done, sir.
Done, na? Okay. So this is the reactivity. So you will have always what? Right, for order of Sn1. See, if you have resonance now, then resonance also stabilizes, and resonance stabilizes the carbocation very effectively. So you will have benzyl alkyl halide, which will be fastest. I'll also write the structures, don't worry. Okay. After that, you will have this 3 degree. After that, you will have allyl. After that, you will have 2 degree. And after that, you will have 1 degree. 3 degree is very, very stable, even stabler than allyl, because there are 9 hyperconjugating structures. If you remember alpha hydrogen, the number of hydrogen in the alpha carbon, sorry, this is carbocation, and after that we have the alpha carbon. These 3 carbons are alpha carbon, and these are what? These are having 9 hydrogens. That is why the 3 degree is very stable. Benzyl is the structure. If you have somewhere CH2X, which is further bonded with benzene ring. 3 degree, you know what is 3 degree. Allyl is X. And if you make the carbocation for this, the carbocation for these structures will be, for benzyl I'm making here only. So this will take part in resonance, and for allyl, positive charge here. So this will also take part in resonance, and hence it will be stabilizing the carbocation. Then everyone is on, please tell me.
Yes, sir.
Right, next, reactivity of Sn2. Reactivity of Sn2. Sn2, please write. It depends on the nature of bulky group attached at alpha carbon. What is alpha carbon? Alpha carbon is carbon directly attached to halogen. Okay. Now, please write. As the number of alkyl group on alpha carbon increases, the number of alkyl group on alpha carbon increases, what will happen? It will create hindrance. Okay, it will create hindrance. It will hinder. Hinder means it will be stopping the incoming nucleophile. It will be hinder the incoming nucleophile, due to which the reactivity of Sn2 decreases.
So the first point could you show again?
It depends on the nature of bulky group attached at alpha carbon. Write these points. Then we will look at the rate. Okay, one more thing, since all of you have my number, let us suppose that you are ill or you are sick or something and you can't attend the lecture, okay, or you're traveling, you can't attend the lecture. Then what you will do, first of all, you will inform me, and then on the next day in the evening, what you will do, you will just message me, sir, please send me the recording of yesterday's class. Okay, so whatever class is going on today, it gets uploaded tomorrow. Okay, so whenever you miss the class, please remember to message me, inform me that you will be absent, and then remind me on the next day to send you the recording. Okay. I should see this number.
Done, sir.
Okay. So let us again see the rate of Sn2. If you have CS3, X, you have CS3, CH2X. Yes, someone is saying something? No. CS3C, CS3, CS3X. Okay. See, the nucleophile has to attack from the backside. Nucleophile has to attack from the backside. Okay. So backside of that carbon, which is having X. So this is alpha carbon, this is alpha carbon, this is alpha carbon, and this is alpha carbon. So you can see that if there is only hydrogen, then it will be easier to attack. But as soon as the alkyl groups start increasing, the attack will be difficult, because if the nucleophile is coming like this in this direction, this will be hindered by the CS3. And please remember, when you are writing CS3, it is not just CS3, a very small thing. It is having carbon and then 3 hydrogens. So as you can easily see, if I show all the hydrogen, then there will be no space for attack. There will be no space for attack. Okay, that is why the rate of reaction, it will start to decrease as I increase the alkyl groups. Okay, so this is 3 degree, this is 2 degree, this is 3 degree, this is 2 degree, this is 1 degree, this is 0 degree. So here the 0 degree will be having highest rate, followed by this, and then followed by that. All of you understood this point, yes or no? For rate of Sn2, why the methyl halide, the CS3X will be fastest? Yes or no, guys? Please tell me.
Yes, sir.
Yeah.
Yes, okay. Let me know if you have any doubts here, okay? What about the others, huh? Samaira, Khalid, Salman, Ania.
Understood, sir.
Understood, na? Okay. Chalo. Assalamu alaikum, Fatima. We'll start the class soon. Just wait for a file. Done, everyone? Is there anyone who's still writing?
Yes, sir.
Yes, okay. Please write. So also remember, Hannah, 0 degree will be fastest, then 1 degree, then 2 degree, and then 3 degree. Your assignments question will be from this. Acha, one announcement is there. Please note. Please make a note of this. अभी भूल जाते फिर आप सबको मैसेज करना पड़ता. You will have a test on Thursday. Okay, you'll have a test on Thursday. What will be the topic? The topic will be last इसमें क्या topic था?
Abnormal molar mass, I think.
इसका तो नहीं ये है ना, ये था शायद. Yes or no? Method of preparation भी किया है हम लोगों ने, right? So your topic will be physical properties and method of preparation and physical properties. Okay. Method of preparation of haloalkane and haloarenes and physical properties. It will be of 10 marks, 30 minutes in the class. And the next class will be of 2 hours. Okay. The next class will be of 2 hours. That means 1.5 hours I will teach, and the next 30 minutes you'll be writing the paper.